Toyota eCVT, Prius taxis doing 300,000 miles, Camry hybrids that never seem to need a transmission, and mechanics everywhere saying the same thing. Never buy a CVT, they're all junk. So which is it? How can CVT be a dirty word in most shops, but Toyota's so-called eCVT and hybrids has one of the best long-term records of any drivetrain on the road? If you're thinking about a Prius, Camry Hybrid, RAV4 Hybrid, Highlander Hybrid, or a Lexus Hybrid, and you've heard, avoid it, it's a CVT, you're being scared away from one of the least fragile parts of those cars. I'm GearHead. I don't repeat rumors. I care what's actually inside the casing, what actually fails, and what actually racks up crazy mileage in the real world. If you want that level of clarity before you spend thousands on a car, make sure you're subscribed, because this is exactly the kind of myth that costs people good cars. Let's break down why Toyota's eCVT is so tough, and why your mechanic is probably wrong when they lump it in with the CVTs they hate. First thing, when most people say CVT, they're thinking of the belt and pulley type. You've seen the diagrams. Two cone-shaped pulleys facing each other, connected by a steel belt or chain. Hydraulic pressure squeezes the pulleys, changing where the belt rides. That changes the ratio, so it acts like it has infinite gears. On paper, clever. In real life, often fragile. Those belt CVTs can be fine if the design is good, the fluid is perfect, the cooling is adequate, and the driver never abuses it. But in a lot of real-world cases, the belt is under huge tension and friction, the pulley faces wear or glaze, fluid gets old or the wrong type is used, and people tow, floor it, and never service it. The end result is shuddering, slipping, metal dust in the pan, and eventual death. Your mechanic sees that kind of CVT and understandably says, CVTs are trash, buy a real automatic. Now, here's the key. Toyota's eCVT and their hybrids is not that design at all. There is no belt, no variable diameter pulleys, no squeeze the belt harder ratio change. It just feels like a CVT from the driver's seat, because the engine revs can stay almost constant while road speed changes. What Toyota actually uses in their hybrids is a power split device built around a planetary gear set and electric motors. Think of it like this. It's more like a differential from another universe than like a scooter transmission. Inside a typical Toyota or Lexus hybrid transaxle, like in the Prius, Camry Hybrid, or RX 450h, you have the gasoline engine, MG1, which is a motor and generator, MG2, which is the main drive motor and generator, a planetary gear set that ties them together, and reduction gears and a final drive to the wheels. Very simplified, the connections go like this. The engine connects to one part of the planetary gear set, often the sun gear, MG1 connects to another, often the carrier, MG2 and the wheels connect to the ring gear. By controlling the speed and direction of MG1, the system can control how fast the engine spins relative to vehicle speed, while MG2 adds or subtracts torque at the wheel side. There are no gear pairs sliding, no belts moving up and down cones, just fixed gears meshing in oil and electric motors changing speeds. That variable relationship between engine speed and wheel speed achieved by the motors and planetary gear set is what makes it continuously variable in effect. That's why Toyota calls it eCVT, electronically controlled continuously variable transmission. But mechanically, it's nothing like the fragile belt CVTs your mechanic is thinking of. Let's talk about why gears and oil are boring, and why boring is fantastic for reliability. Clean, correctly hardened gear teeth rotating in oil with decent bearings and no shock loading, that's the least dramatic thing you can ask for a machine to do. Toyota's eCVT gear set has no multi-plate clutches for each shift like a normal automatic. It has no band servos. It doesn't bang through gears 1 through 6 under load. It just constantly meshes the same way. Power is blended by electric motors. The gears themselves see fairly smooth torque, not harsh shifts. Compare that to a traditional automatic, which has multiple clutch plaques engaging and releasing, a complex valve body or mechatronics unit metering fluid under high pressure, and torque converter lockup clutches. There are lots of chances for wear, glaze, and valve sticking. Compare with a belt CVT again. There are huge side loads on the belt and pulleys, constant microslip at the belt and pulley interface, and a sensitivity to fluid condition and temperature. From a mechanical stress standpoint, Toyota's hybrid transaxle has it easy. The next big piece, and this is huge, is how Toyota understresses this design. They didn't design these eCVTs for 500 horsepower drag racing. They designed them for taxi fleets, commuters, and families who change oil late and ride the brakes. So they left massive safety margins. The electric motors, MG1 and MG2, are sized for continuous duty, not just for 2-second bursts. They're liquid-cooled and run in tightly controlled temperature ranges, and they're driven by inverters that Toyota tunes conservatively. The gear set has tooth sizes and materials chosen for long life at the torque levels these cars see, not for showing off huge torque figures on a spec sheet. And importantly, the hybrid system shares the load. MG2 helps the car get moving from a stop. The engine doesn't have to be hammered off the line all the time. In city driving, MG2 does a lot of the low-speed work, and the engine often joins in at more efficient RPM and load ranges. That means fewer brutal floor-it-from-every-light with a cold engine cycles going through the mechanical parts all the time. Everything about the hybrid setup is aimed at smoothing and reducing mechanical abuse. Less abuse equals longer life for gears and bearings. Now, what actually kills these transaxles when they do fail? Because unbreakable is still an exaggeration. There are patterns, but they're almost always about heat and fluid, not the design itself.
3 big things can hurt a Toyota eCVT. First, overheating, especially if the engine or inverter cooling systems are ignored. Second, wrong or filthy fluid. And third, catastrophic engine or inverter failures that contaminate or overload the system. Let's look at overheating. Toyota hybrids have multiple cooling loops: engine coolant, inverter and electronics coolant, which is separate on many models, and transaxle fluid, which sheds its heat partly through the casing and sometimes through dedicated cooling. If an owner drives with low coolant, lets the engine overheat and keeps driving, or never services the cooling system over 10 to 15 years, they risk warping engine parts, stressing the inverter, and pushing transaxle temperatures higher than intended. The eCVT will usually tolerate some heat abuse, but repeated overheating is how you start to see breakdown of fluid film, bearing distress, and accelerated wear. Regarding fluid, Toyota often calls their hybrid transaxle fluid lifetime in some marketing. Technically, what they mean is lifetime of the warranty or average ownership, not it magically stays perfect forever. Heat cycles, moisture, and fine wear particles still accumulate. If you never change that fluid, and we're talking 200,000 plus miles with lots of hot city duty, you're asking it to keep doing a perfect job beyond its chemistry's limit. Is that still usually better than a neglected normal automatic? Yes. The point is that fresh fluid is cheap insurance, even on an eCVT that isn't screaming for it. Then there is contamination. If an engine blows and sheds metal, or an inverter goes in a particularly ugly way, or a bearing inside the transaxle starts shedding material, that contamination can circulate. That's not a design flaw of the eCVT. Any gearbox hates metal in its oil. The key takeaway is this: if you keep the engine and cooling systems healthy and you give the transaxle fresh fluid once in a while, you've removed 90% of what can hurt it in normal use. So if the eCVT is so good, why are mechanics so loud about never buy CVT? Because their sample is biased. They see blown Nissan CVTs with shredded belts, a few early Audi CVTs that were nightmares, people hot-rodding Subarus with belt CVTs and killing them, and normal automatics that were fine for decades suddenly being replaced by CVTs that didn't handle the same abuse. All of that is real. But then they hear Prius has a CVT and their brain goes CVT equals belt equals bad. They've never rebuilt a Toyota eCVT. They've never seen piles of them fail, and they've never had customers lining up with dead hybrid transmissions at 100,000 miles. So they extrapolate their belt CVT pain to Toyota's completely different design. It's like saying, I've seen a lot of cheap plastic timing belt tensioners fail. Therefore, all timing chains are junk too. It's the wrong conclusion off the right experience. Real-world fleet data tells the actual story. Look at taxi fleets, Uber and Lyft drivers, delivery drivers, and high-mileage commuters. You'll see Priuses with 250,000, 300,000, and even 400,000 miles on the original eCVT. Camry Hybrids with 200,000 to 250,000 that have never been opened, and Lexus RX 400h and 450h where the suspension and seats are shot, but the transaxle is still fine. If that eCVT were as fragile as the CVTs your mechanic hates, taxi companies would not be filling fleets with them. They'd be huge money losers.
Instead, around the world, from Los Angeles to London to Tokyo, Toyota hybrids are some of the most common high-mileage, low-drama vehicles on the road. That doesn't happen if the core transmission is junk. Now, here's where you should actually be focusing if you're worried about buying a high-mileage Toyota or Lexus hybrid. Focus not on is the eCVT going to blow up, but on how's the engine, how's the cooling system, how's the hybrid battery and its cooling fan, and how's the body and suspension. Let's start with the engine. Certain Toyota hybrid engines, especially the Gen 3 Prius 1.8-liter, have known weak spots if they're neglected. EGR clogging leads to uneven combustion temps, which creates a head gasket risk. Long oil intervals lead to sludge and ring sticking, causing oil consumption and extra stress, and overheating leads to head warp and gasket failure. If someone says, "My Prius died at 180,000 miles," dig into what died. Often it's the engine, not the eCVT. Then there's cooling. If the radiator, inverter cooler, or water pumps have been leaking or weak for years, everything in the drivetrain has been a bit hotter than it should have been. That slowly kills electronics and heads long before the gear set. And the hybrid battery and fan. If the battery cooling intake and fan are packed full of dust and pet hair, the pack runs hot. That kills cells early. Then people blame hybrid systems when it was actually airflow and basic maintenance. None of those are the transaxle's fault, but from the outside, it all gets lumped together as hybrid problems. Where does that leave you if you're considering a Toyota or Lexus hybrid with an eCVT? You should not be scared off purely because someone said CVT. You should listen to the transaxle on a test drive. There should be no grinding and no abnormal whine. Check for hybrid system codes with a scan tool, especially anything pointing to MG1, MG2, or transaxle temperature issues. Check the fluid if possible to ensure it's not burnt and not silver glittery. Make sure the car has never been driven seriously overheated by asking the owner, looking for evidence of headwork, and checking for smells. And get a hybrid-savvy shop to do a pre-purchase inspection. If all that checks out, the eCVT is very likely to be the strongest, most overbuilt part of that drivetrain. If someone at a random shop says, "I'd never touch that, it's got a CVT," you can politely translate that in your head to, "I'm familiar with belt CVTs that break, and I haven't really looked into how Toyota's hybrid transaxle is built." That's not a reason to walk away from some of the most proven, long-lived drivetrains on the used market. So, is Toyota's eCVT literally unbreakable? No, you can break anything if you try hard enough. But compared to belt CVTs, fragile dual-clutch automatics in the wrong use case, and overly complex 8- and 10-speed automatics that are abused and never serviced, Toyota's eCVT is one of the lowest-risk, highest-longevity designs you can buy right now. If this helped you see why saying CVT equals bad is way too dumb a rule to apply to Toyota hybrids, make sure you're subscribed. Next, I'm going to dive into the engines Toyota bolts to that eCVT in different generations, which ones are nearly as bulletproof, and which ones have specific weak spots, like that Gen 3 EGR and head gasket combo that you need to know before trusting them past 200,000 miles. I'm GearHead. Every drivetrain has a story. And together, we're going to decode the ones everyone loves to trash and the ones that quietly outlive almost everything else on the road.